Hello, everyone. Welcome to the first ever episode of the Code and Coffee Show. It's Code and Coffee Show because, code and coffee are the two most important things for each developer. And yeah, you can see we have a lot of coffee. And I can say that we also have a lot of code prepared for you. So today we will talk about the thing that many developers don't like to do, but this is the thing that most of the developers should do. I mean, application testing. And together with Christian, we will try to show first how to break an application because yeah, we have to. And then we will try to refactor it and cover with tests to show how it should look like. And with me, I have Christian Dangl, and he's the head of technology at the Shopware agency dasistweb. He focuses on system architecture, software architecture, automation, integration, and QA. In addition, he is also the owner of the Live Score and likes to give training courses and lectures at webinars and conferences. And that's why he is here with us. Hi, Christian. Did I forget about something or did I remember about everything?
No, it was perfect. Thank you so much for that kind introduction. So, hi everyone. It's great to be here. Same guy, new show, but always a wonderful experience with you. Thank you for
Yeah,
inviting me.
because in general this is our third webinar together, so
Yeah.
yeah, this is great. So before we start talking about the code, I think that let's start about uh, the, the another important thing for every developer, the coffee. So do you consider yourself as a coffee drinker?
Yeah, I'm not so well educated when it comes to the whole history and stuff of coffee, but I'm so addicted to it. I just can't tell you.
Do
I
you have
think
some favorite type or?
Um, I personally prefer it when you really have the feeling that you have something in your mouth. So probably not so much those water-based filter coffee. So I'm pretty much into those small espressos where as intense as possible, high intensity. And yeah, I kind of drink probably too much. I would say at least 10 espressos a day. Could be less, I think, but I'm just totally into it. And but on the other hand, I drink 3 liters water every day to have the
So yeah,
balance.
that's
What
yeah,
about you?
that's okay. And in my case, I'm on the other end because I prefer all those filter ones. Although I also like a good espresso, so it's not that I don't like it, because with espresso it's really a bit more difficult to find a good one. So but I know that a good espresso is really so
Mhm.
full of flavors. It's like in this explosion of all the flavors in your mouth. So it's, yeah, but I honestly, I wouldn't be able to drink more than, I think, even two or three. So we are,
So
and
not
when it comes to when it comes to espresso drinking, you are the master here. And yeah, and right now, for example, I have this Ethiopian coffee made from the Hario V60. It's from this Polish roastery called Roasters. It's really nice. So yeah, it's I definitely would say that it's always worth to try. So, Christian, before we will jump into the coding part,
yeah.
yeah, the bills won't cover themselves, but luckily, I am lucky enough to have a very generous sponsor, and yeah, the next 20 seconds are for them.
Kinsta's application hosting simplifies the work of modern web developers. With just a few steps to get your app up and running with performance backed by the fastest Google C2 machines, Kinsta has built a development platform designed to get your applications in front of users as quick as possible. Test Kinsta's application hosting for yourself at kinsta.com. The first $20 are on us.
And we are back. So yeah, it's time for the coding part. So, Christian, what have you prepared for us?
So I have prepared something hopefully very interesting for you. If you could just start to share my screen. So the overall topic today is testing your PHP application as good as possible. One of the things that I usually see out there is not people starting from scratch and already starting with tests, but as people having an existing project and then start to cover it with, let's say, unit tests and other aesthetic analyzers, stuff like that. So that's in most cases what I saw, and in most cases that's pretty more complicated to achieve in the end. So today I did prepare an e-commerce payment plugin. So I'm working with the platform, the e-commerce system Shopware, and also doing the Molly, the official payment provider Molly plugins for Shopware 5 and Shopware 6. And I've prepared a custom-made Molly payment plugin today that just has one payment method. And our customers told us that there might be a bug in it. So we have to figure out what the bug is, find the part in the source code, and then the request they told us is to make it solid proofed, to improve it in general, fix it, and every code quality measurement that we could do, we should try to do it. So that is typically one thing you might face out there if you have a wonderful customer such as Molly that they just say, go ahead and do unit testing. Doesn't happen all the time, unfortunately.
I would say that it happens quite rarely. It's like you have to start this small battle about do we have time? Should we do it? And in many cases, you are just doing, you are adding tests after hours to have like... So you don't have to worry every Friday evening about what will happen during the weekends.
Exactly. So developers out there, just ask your customer if they have a car insurance or something like that. And if they say yes, then just ask them why, because it pays off when you need it. Okay, so I would say it's the coffee and code show. We have coffee. Now the code is missing. Let's head over to our code. Let me just first start to show you what it's all about. So this is a Shopware 6 default installation. There's a listing, the products. Let me add something to a cart. Log in, because I've prepared it a while ago and my session is already gone. So this is the final confirmation page where we do see available payment methods. And from the set of Molly payment methods, I've selected P24. Maciek told me how to hopefully correctly pronounce it. So
amazing. I'm so happy that our chats are our chats are always really interesting because we cover so many topics, and I never thought that pronouncing this Przelewy 24 will be something useful. And hey,
it is. I'm probably one of the only people, at least where I live, being able to say it. Anyway, so I did already select the payment method and check boxes, and I submit the order. So what happens? We see a sandbox screen, which isn't coming in production, obviously. But what we do see is we have to enter our email address. So that's kind of weird, isn't it? I continue. Then I can say, okay, it's paid, sandbox mode, continue, and I'm on the Molly page. So what did we have here? Probably the last thing is the bug that we heard from our customer. So we should be back in the actual shop, right? The other thing with the email address, that is kind of weird. So let's just keep it in mind. So if we go back to the shop, open the administration for Shopware, there is, just to let you know how the system works, we have an overview of all plugins. So we are mostly building plugins in Shopware. And there's the Molly Payments plugin, and it has an API key. So just keep that in mind. Let's open PHPStan. So as soon as we've digged a bit deeper into the code, so that's the thing that I will do for you now, obviously, is there is a class for the P24 payment method. And that class has a pay function as well as a finalize function that we do not need today. So the pay function has the bug in it. It has a hard-coded redirect URL to molly.com. The other thing with the email address is just a missing argument in here. So that's the analyzing stuff that it is as it is. We already know the solution now. So let me fix that thing for you so you can see it at least once. Get URL, return URL, and then we also have to provide, I think the billing email should be from the transaction, get order, get customer, get email. All right, so let's repeat that step. Add something to our cart. Submit the order, and we are already on the page where it says payment status, so that billing email did work. And we select paid, and we are now back successfully on the thank you page of our Shopware shop. So that is how it should look like. So we know how we fixed it. Now the customer asked us to do something that it doesn't ever happen again, and basically improve the overall code quality. So this is where we start. The first thing is there are indeed many things nowadays that you probably want to have, or let's be honest, need. So we have not only testing, unit testing, we have static analyzers such as PHPStan, we have PHPSFix. But on the other hand, when it comes to the end-to-end components, we have things like Cypress and other testing frameworks. So you need all of them. To be honest, we have so many devices, so many capabilities, options out there, you never know. I just can't tell you everything in that particular show tonight. So we are focusing on the main part where it comes to unit testing, because unit testing, if we have an existing project, automatically leads to code refactoring. And there are some obstacles and things you usually do. So still, so we know Cypress today. But before we do that, we have a makefile. And I did at least pre-install PHPSFix as well as PHPStan. Let me show you the composer.json. So there are instructions out there, so you probably know how to install it. With our makefile, so that's the first thing, I can run stan. So I would always recommend at least having some levels. You can't just start with the highest level, obviously. But let's try to figure out what happens if we run it. We already know a few things, speaking of quality, that are just wrong. That means first thing before we even start with unit testing is we try to fix those things that PHPStan told us. It says in the plugin configuration, if we open that one, I will guide you through the classes anyway, don't worry. So this one is a basic class that gives us access to our plugin configurations. So the part in the administration to get the API key that was entered. And it tells us that in line 29, the get API key should return string, but returns array, bool, float, whatever. So it's probably this one. Yeah. There is a different thing that we can use, get string. We know it's a string in that case. If I rerun PHPStan, that error is at least gone. So what PHPStan or static analyzers basically do, they try to find errors in your code without actually running it. So that's called static analyzation. And it helps us to already prevent a few things, because the next one is probably coming in a dynamic way if it comes. I mean, this one is probably no real bug because there's always a string inside. The other one could be. if we open P24 PHP, it says in line 50, can a call get mail on order customer entity null? That means every transaction has an order. Every order has a customer. And that customer is either a shopper entity or it's null. Both, speaking of the structure, is possible. If that happens, we have a crash and exception in our system. So how do we usually treat things like this? One option would be to say, okay, customer is transaction, get order customer. So that's a nullable order customer entity. If not customer instance of order customer entity, so that's a special entity, not just a customer one, then throw new exception, ABC, whatever. If we now rerun PHPStan, same error is still there. Why? Because we really need to use that one down here. So as you can see, PHPStan is pretty smart. It figures out that if that if condition, if it didn't exit our code, down here it's always an order customer entity, and therefore it's valid always. If I rerun
also, I would add one more thing about PHPStan. I mean, PHPStan is so easy to configure from because creating unit tests can be kind of difficult, but when it comes to configuring PHPStan, it's just installing and configuring the config file. Oh, I think that that's it.
Yeah.
You just have to add one file, run it, and it will do most of the work for you. I mean, you have to fix the code later, but at least it will find the bugs. I mean, it kind of transforms PHP into C++ when we have all those problems during compilation and everything. And PHPStan is doing so. I know that many people decided to use PHP because it wasn't so strict about variable types, and thanks to first of all, strict typing and using PHPStan, we can make PHP much more strict, which might not be something so nice at first. But
you, as a WordPress expert, you probably face a lot of different code, right?
Oh my.
Oh my,
yeah. Oh my. I mean, let's remember that I think that WordPress, I'm not sure would it run on PHP 5.6, but there is a chance that like 2 versions ago it still would work on it. So it didn't take care about things like types or anything. But still, it's the most popular CMS, let's remember.
And a widespread of developers means a widespread of quality, right?
Exactly.
That's also one of the funny things, because I'm pretty much a fan of PHP. Speaking of the versions recently coming out, that they are trying to get more strict with still having some kind of backward compatibility. So, because that's one thing that I always say is the new things you have in PHP, you could always do the same thing years back then. So it was always possible to have this same old school quality type safe things such as you would do with C# in PHP. The only thing that is the major problem is that you were flexible to not do it. And as soon as you have the option to just be more lazy and not so strict, you'll usually do it. So that's a fascinating thing. So that's the only thing that changed.
I won't lie, this was the reason why I started learning PHP, because I remember that when I learned C++ and Ada, with the strict typing wasn't my favorite thing. And when I saw PHP, and it was so, and I could feel the freedom that it gave me. And after some time, I realized that this freedom is kind of leading to chaos. And
Exactly. Good words, man. Good words. Leading to chaos. So leading to a better quality is what we are doing next. So let me just close a few files. Now that we have at least PHPStan green, let's figure out how we can actually introduce some tests, some real unit tests, because that is the main focus for today or tonight. So our goal is not to only try to make sure this one is tested, but also to add some overall quality. So first thing, install PHP unit. PHP unit composer require PHP unit. That's it. Then you have a PHP unit XML file. So I just go through it because it's easy. You say, okay, here are my tests, probably in a test folder. And this is for the code coverage, our source folder. So when you start with unit tests, start easy, especially if you're not used to do it. That means the first thing, if we take a closer look in here, is we have this format value. So let's just try to figure out what this is. In Molly, in the payload, if you have float values, they always need to be sent as string, as well as a fixed decimal point with 2 decimals as string. So this is at least something we could start to test because it makes sense, it helps, and it's a nice start. So first thing we discover is we have a P24 payment class with a public function format value. Would you really do it? Obviously, no one really uses that class instead of Shopware itself, and that's interface-based with pay and finalize functions. So that is, let's be honest, a private one. How could we test it then? We shouldn't test private classes, private functions. Private functions are tested implicitly, but are not the subject under test. So one idea would be to create a new service for the formatting. So we create services. Oops, that's here. And let's say just format number service. Oops, singular. Okay, I just grabbed the code. Public format value. Here we are. Now the only thing we need to do is to use it. Let's do a private formatter. And now the funny thing, especially for classes like this one, do I really always need to have dependency injection? If I don't have real logic that have different behavior depending on constructor parameters, probably not. And let's be honest, I don't want to test it, mock it. Let's just do a new format number service in here. And then all we do is we just use it. Formatter. Okay. Formatter, format amount. So I actually started wrong because that would have been the last part. Why the heck do we do this? Because to make it testable, because private functions in here, it just wasn't possible to test it. So we extracted it to a different class, and now let's create a unit test for it. So my recommendation would be to have always the same structure as with the main code. You don't have to, but it might be a good thing. And then we just create a new format number service test class. Let's do a I think it's Kida Molly payments tests probably. Just double check with my backup. Okay, so first thing is I extend from a test case in PHP unit. That is always required. Then when I start, I just start with public function test and think about what I will test. Because one of the things that avoids me from creating good tests is me not starting. Now I start to realize, okay, what am I going to do? First thing is I need a new object. So I have a formatter, new format number service. Now I think about, okay, what do I actually do? I use format value because that's the only public function, and just say 5. So that has a result. And I use this assert equals, which means I can say ABC should be the result. And then let's just run it before we make it beautiful. Again, I have a make file because I always tend to switch between all these kinds of different projects. So this would be the configuration with code coverage for later on. All I do is make PHP unit. And I do have an error. Who would have seen that coming? Because 500 is not the same.
It's not the ABC. Yeah.
So we already know this is the expected behavior. So I fill it in and say, okay, test format value. Now it's green. Perfect. So what do we see in here? We see a class that always needs to start with test. Otherwise, you would need to use that thing that deprecated test annotation. So just start with test. So it's really called. And then we have the AAA. Means we have arrange, act, and assert. And no matter how many things are being done in here, it's basically always the same. If we would have the P24 payment method, especially the arrange would have been way, way, way too complicated and probably not even possible. So that's why we've extracted to a separate class. I mean, one could, in theory, use it in a different service where you don't want it to be used, but what the hell, it's tested, so whatever. Now, the next thing is if we really want to test more, there might be additional things like free, and then it's free. For things like this, you could create data providers. That means usually get test data returns an array. When you test, you usually automatically, in most cases, if you're a bit more experienced, decide what makes sense to be tested. Does it make sense to test 5 and 3?
Not at
Probably
all.
not. Not at all. It would make sense to test 3.29 and just 5, because the format always has to be 2 decimals. And to cover all these different options, only if it's always the same test, kind of a test, and you can use data providers, and then you have the same test with different input values. That means we return we return a list of data. So expected would be 5.0 for the value 5. And for 329, it would be 329. We assign a data provider in here, get test data, and obviously here we have the string expected and the float value. And we have expected in here, float value in here. We run, and here we go. It's
failed.
Oops, 29. There is a cannot redeclare. Oh, oops.
Oh, yeah.
That's the small resolution, the low one. Okay, so we have 2 tests, 2 assertions. In that case, we could easily extend our things that we have in here. So now, let's imagine we have a lot more tests. You might ask yourself, how can I figure out what else I could test? Am I missing something? Because you're probably missing something in here. There is something called, before we head on to different types of unit tests with marks and stuff like that, there is something I would also recommend using, the code coverage. So in the makefile, there is the option, I do have xdebug mode coverage, so it's working, and a coverage HTML report being generated. So if I rerun that one, it says generating code coverage. What is code coverage? It tells us, if I just open the report, index.html, open in Chrome, and probably need to open it in this window. Code coverage means how much of your code is being at least executed inside a test. So that's the test code coverage. If we go to services, we see that our format number service does not have 100%. So there is something that can happen that leads to a code not being tested. If we open this one, we do see, oh, it's probably a null argument, which should return 0 for whatever reason. That means
we have to test for null.
We have to test it. How can we do this? We just create a new, in that case, I would really create a new test and not just a data provider entry, because it's a different kind of test. I mean, it's the same, but it's different. And one of the things that I love to share, I mean, let's be honest, if you're familiar with PHP unit, that is easy for you. But what might not be easy sometimes is the psychological approach of testing. What is really tested and what do you see in here? Because that might be totally different thing. So, and it's always about reporting. We want to see that the null problem is red. So test format value with null. We don't need any arguments in here, no data provider. We just say null. And what should happen? I think it is 0, 0.
0.0. Yeah.
So make test, and it's green. And if I do refresh this one, now we have 100% code coverage. 2 more things on that. This doesn't mean anything. So it just means that everything is at least being run in a test. There is something called mutation testing, where you create mutants. So one of the things is, let's say you have an is adult, is the person greater equal 18. And if you, a different developer could in theory make a greater 18. And if you didn't test the gap where it transitions to the other one, so there's no unit test for the transition case, that means a different developer could change the operator and no test is read. With mutation testing, you create such mutants of your source code, basically a full snapshot of your source code with different variations, and it requires tests to be read to find this error. And that means mutants are either escaped or are killed. And you want to kill as many as possible. So that is future or a long-lasting development to really think about not only testing things, but testing things that are important, that might break in the future or might even be read if the source code changes in a different way. So that's one thing, just to let you know. It would be too much for today. The other thing is crap. So the crap indicator, crap index, means the more crap basically you have, the more it comes from the complexity, cyclomatic complexity of the code, and also what is tested, what is not tested. So if you have files with crap indexes that tell you this could be a problem, maybe start with these files to test as soon as you are experienced. If you're not experienced or just start fresh, just go with an easy approach like this. So I think that's hopefully easy enough for every level of developer out there. Okay, so now that we have at least done one good thing, let's do another one. So a small one that you could use is creating constants. So we have the payment method, which is this string, and it's probably specific to this class. So let's just create this one, because every payment method, so there are a couple of payment method classes, probably have the same approach. So we create a public static const molly ID, and this is that string. And oops. Self and molly ID. And then we just create a test in PHP. We have handler method and then a P24 payment test. So we repeat the same things in here. Test its handler method. This case, I know some things could be generated. I know, but I'm just doing it that way always. Okay, test molly ID. So this assert P24 payment, and we have the correct string. So why do we test things like this? I mean, that's easy. Also getters and setters. Let's just face this. You have a class person, and you have a private first name, a private last name, and then you create a public public construct, public function. Don't you worry, I'm not stupid. I'm just using too many different languages. That's why I usually do it like this. So, okay. Let's do string first name, string last name, and then you create this first name, then we have the command D, and then your colleague asks you something. You get a call or anything like this. You come back, you do public function get first name, get last name, and return this last name. There's a bug because it's not assigned correctly. And this is the reason why I always say you can test smaller things because they matter. You don't have to. Sometimes I'm arguing with some people, getter, setter tests. Do they matter? Are they too much? Just with that approach, they matter. But it's not always required. So that means I also test constants, also because it's more meaningful. In that case, I always tend to do descriptions. This test verifies that our molly ID is not touched. It's required for the molly API to identify the correct payment method. And now we did something good. We prevented the future developer from breaking things. We have a documentation why we need it and what it does. So all these kinds of benefits just with a simple, kind of stupid unit test, but it makes sense. So these were the, I would say, easy tests. Now we come to some more advanced stuff. Some coffee before.
Cheers, yeah.
We start with the plugin configuration. So the plugin configuration is something that requires a different kind of service. And that is done using dependency injection. We have the system config service of Shopware being used. And we try to test this particular line of code that the correct key is being returned. So I do create a folder in my test structure for components. And I think it's plugin configuration. Plugin configuration test. So again, extends test case, public function, test API key. Next, how do we start? So I would probably create a config is new plugin configuration. And now I have the first problem. It requires a system config service. The system config service is in Shopware a class. There's no interface or anything. So how can I fake something like this to use it in here? Because all I need is just this one. But that's what I said at first. The arrange needs a bit more. In that case, I could use mocks. So I create a mock system config service. And I create this get mock builder, system config service. I just tell him what class to mock. Basically at runtime, that's kind of proxy class, a different kind of class. Then I disable the original constructor and get the mock. Now I have a mock. What can I do with a mock? With my mock, I can say expect this any. That's just what you need in here. And just do it fluent in that way. And then I can do this one. Method get string. That's what we used. With this equal to will return fake key. Let me just copy this one. So that line of code, we have this, and this is the same. As soon as this, anytime, not just once, you can, in theory, just make sure that it throws an exception the second time. But if that one is called anytime, this function with this argument, then this is returned. Now we can proceed. We say, okay, mock system config service. PHPStan would tell you there's no system config service. That is a mock object. So we can simply say, okay, for PHPStan, this one over here is a mock. And from here, just treat it as it would be a a system config service. And now all we do is get API key, and this assert equals fake key is API key. We run our test, and it's green. If such a complex thing for me is green, I always try to make it red again, because I don't trust myself. Okay, it's red.
And it's red, yeah.
Back to green, and we have a valid case. So that's how you mock. You create mocks, you create stubs. I skip on the explanation in that case. The main thing you usually do is either get fake data to be used or create for kind of integration testing, make sure that a mock receives some data, maybe a HTTP call receives the correct post parameters. The problem with mocking is that it's kind of complicated. If you have all these kind of mocks, you really end up probably with something like this. And it depends on how many dependencies you have for your service in the injection part. So mocking is good, but on the other hand, mocking isn't that good if you can avoid it. In fact, I mentioned that I have a couple of languages I'm using with C#. I tended to be a very bad architectural designer when it comes to testing concepts. So I had a testing framework that cost me a few $100s just to create mocks a year. That was a subscription thing. So I was able to get rid of it for free by using just interfaces, changing the way how I develop, and then I didn't need any mocks. With PHP unit, it's free, but it's the same story. And this is why I will show you a different approach that you can also do now. So the last thing we have today is the actual thing that we want to test to make sure that the error doesn't happen again. So I know it might be a bit complicated, or could be a bit complicated. So please try to focus that we try to test that thing that is being sent to Molly, typical HTTP network driven tests. How can we actually test such a thing? Molly would have an interface, but I would love to show you with some kind of adapter pattern or wrapping element in case you don't have one, or even final classes and things like this. So we try to get rid of basically this part, building the parameters, creating a Molly API client, setting the API key, and sending it and receiving the payment, which gets us just our redirect URL. And that requires refactoring. So first thing we do is we create a new component, Molly. I just call it Molly. Then I create a Molly class for it. And then I will probably do something like public function, create payment, maybe the string method name, maybe the float total amount. We want to receive a payment as API resource, just as we had. And that's it.
By the way, this is something very important about testing. The moment when you start writing tests, you probably very often start seeing how you need to refactor your code, like automatically, because you will start seeing those places when you either will spend hours trying to make the test work, or just by simple refactoring, for example, moving some things around, you will see that your code will become much easier to test, and you will have, I don't know, an hour of your free time, because you will have a test, more testable code, and everything will work. So, but yeah, really, when the moment when you start writing tests, very often you'll see how much refactoring you will have to do just to save yourself a lot of time.
Exactly, and this is what we will be facing in the next couple of minutes, because that change isn't done in a very easy way, because we could simply move that client stuff to a different class, but we have dependency to our plugin configuration, to our API key, and to probably order stuff and other things. This is where it gets tricky, and we are in small steps, baby step refactoring, and see where we end up with. That's it. So you could do the test-driven way. So that means we write the test immediately, and then it's red and make sure it's green in the end. But I don't know where we come out. I mean, I prepared myself, obviously, but let's just do a free refactoring. So I want to use the Molly component in here. So that's at least something I know. Molly. Then let's just create a newable here, new Molly. Doesn't have any dependencies at all. And down here, I say, okay, my payment is actually from my Molly. I create the payment, use my Molly ID and the order transaction order get total amount. Is it the, I already have the amount here, sorry. Perfect. So this is where I want to remove that part because it's substituted and replaced by this easy thing. Let's place it in here. Okay, so now we have new stuff coming up. We are missing our formatter, meaning private formatter. Oops, number formatter. We create a constructor. Yeah, probably let's renewable in here. New number formatter, and then this one works. Perfect. We have the total amount as an argument. We have the method as an argument. We probably still need the return URL and the string email. Return URL, email. Perfect. So let's just add it in here. And you can see that I'm already refactoring more and more. I'm trying to figure out what the heck I'm actually doing. In the end, I want to have good tests. So we have this. Next thing is that part with the client. And probably this return. We can already do it. So how do we get rid of this and what do we actually want to test? So we can test a builder object that returns us a array or JSON payload. So that's something I would also recommend, but I want to focus on network traffic and HTTP clients. Let's get rid of this. We are using a private client. And this is a Molly API client. This Molly client is new Molly API client, and it needs an API key. So now we have a new requirement. We need an API key. Not quite sure if that is really, no, that's wrong, but down here. Okay, so we have something new. That code down here looks pretty nice. We can't still test anything. So what do we actually want to test? We want to test this part. We want to test that the exact payload is being sent to Molly. Can we really test this one? Probably not. But what we could do is something like this. We create a new subfolder and call it client. I do create a Molly client adapter. And that Molly client adapter has a public function create payment, and it gets an array params and returns a payment, obviously. I do place this one in here and probably private client constructor, this one in here. We have our string API key. We have our. So what do we have in here? This sounds a bit yeah, ridiculous, but it will make sense in just a few more minutes because it's just a one-line wrapping function. Let's use it. So instead of the Molly API client, we have a Molly client adapter. We create a client is new Molly client adapter, and we have our API key in here. I probably need to return something else. Return this client, create payment, params. Okay, we're almost done. We now have something new. We have the option to have custom code, because it is custom code that receives our parameter object or array, JSON array object. How can we test it? Let's do a test. Components, let's just create a folder for Molly. Still not so much used to the new UI in PHPStan, but whatever. Molly test. Send test case. Public function test payload, because I already know it. Oops. Then I create new Molly. Molly is new Molly. Needs an API key. Yeah, don't have one, whatever. Then I say Molly create payment. I say, okay, that's P24. That's the return URL, HTTPS. Yes. PHP unit. I do have an test at phpunit.local and probably full amount of 49.90. That gets me a payment. If I now do the assertion, I'm wondering, what could I assert? Because there's nothing really done. There's network traffic required. And I actually don't want to test this. I want to test what is being sent to Molly. And now comes the tricky and fun part. And suddenly, I hope it's like, you got it. I will use an interface for this. So I create a Molly client adapter interface. Molly client adapter interface, and use that signature of my create payment as the one or the only function in here. And Molly client adapter interface will implement it, and nothing really different. If I go to the Molly component where I use it in my real code, I just change this one to the interface. No change. But now, instead of providing the API key, I will provide a Molly client adapter interface. And assign this one. And if I go back to my test, it requires an adapter. And now, because I have an interface, instead of creating mocks, I could create a real interface-based implementation, meaning I create a folder fakes, for instance, and say fake Molly client or adapter, implement the Molly client adapter interface, return a new payment with a new Molly API client. That's just, it's possible. That's just working. Just stick with it and believe me. But the other thing that I can do is create a private use params object. When create payment is called, I assign it and create a getter function to access this one. And now in my test, fake client is new Molly fake adapter. And in the assertion, I can now fake client get use params. This one probably be an array. Expected is always do some shitty values in here, because sometimes you really have empty arrays being returned, and then your hopefully red test is green for whatever reason. Already had that in the past. So Molly payments test fakes. I screwed up namespace. Really sorry for that. Molly payments. Kia Molly payments tests. Tests. Yeah. Tests and
Expected is 2 parameters. Yeah.
Did I have a wrong in Molly test payload? Oops. Expected Molly come 29. Oops, that's the wrong one. Number format. How did I call it? Format number service. Sorry.
Format number. Yeah.
Number service. Okay. Now we have this one. I go to the Molly test. Fill this one in. Again, for the substructure, I mean, you could also build it yourself, but amount. And then all we need is the value and the currency that is still missing. Okay. It's green. What we have in here now is we use the real class, the Molly class. We build a payload, send it to an adapter that usually, that's the only thing that's not tested, but then we have Cypress tests in the end for the full end-to-end stuff, as an example. But in our test, we test it against our fake object, fake client, where we always know what is happening. Let's do a second short one, so you see the power before I do have something to consider, because it's additional code, fake exception, Molly adapter. This one implements the Molly adapter client interface. And I know that it can happen that a new API exception from Molly comes with a, let's say, this message. And if we use this fake adapter, we get the behavior as if in reality an exception is being thrown. So if I create a test, a second test exception is being thrown and passed on correctly. I mean, that's a very long one, but whatever. Fake exception adapter client, my exception. I don't need this one. I don't need this one. I just create it in my test. I say this test expects exception, API exception class. I can also do my test, for instance. And it's green. If I would remove it, it's red. So that means we can easily, by simply having different types of implementations for our fakes, for our kind of mock stuff like that, we can easily change the behavior, what our subject under test does, and how to simulate different kind of approaches. The only downside is this is all custom code, additional custom code. So if you go with that approach, keep it simple. No if condition stuff, very just a few lines of code, but then it's really powerful, because if we come back to the plugin configuration test, that gets tricky. And what it also does is, as far as I know, I think I need this line of code. He expects. Probably not, but I do see people having it. And what it does is, it doesn't make any sense. It would only make sense if we do it like this once. But it does not only test the fake key is being returned correctly. It also tests the amount of calls that mock object gets. And that's, let's be honest, a totally different test. And this is what I face the problem with mocks, that you usually tend to test things that you wouldn't know that you're actually testing by just writing your test. So it can get complicated. So maybe try to go with these that interface approach. It's actually the better approach anyway. If you just face C++ stuff like that, you had the implementation header files separately anyway. But that's one thing. The last sentence for the actual code is, obviously, we need to, that's just too much for today. We need to create a new real Molly implementation that really calls the actual Molly client in the real code. That means probably go with a factory service dependency based on factories and create the real adapter, not the fake adapter in the real code. The only thing that's not tested, but you could still test it, is the small integration part, the wrapping part, where you create the real logic. But that is usually a one-liner anyway. So that's just one thing to mention. But these are all just a small step for quality improvements. And our goal for today was that we test that the correct data is being sent to Molly, and that our bug is resolved, and that also our found billing email is in it. If that is returned, for instance, we would get the Molly sandbox page again asking us for the email address, which we can prevent with that unit test. All right, that's it so far.
Yeah, and I mean, we covered a lot. It was about an hour, and as we started at the beginning, it is just the beginning of the long road when it comes to testing. Because before this show, like yesterday, we got this we got the discussion what we can test currently with all the tools that we have, and the amount of tests that we can, not always should, but we can write, and the amount of aspects that we can cover is like huge. I mean, because we can start with unit tests, we have functional tests, we have end-to-end testing, and then we can go into because there are kind of end-to-end testing, like all those accessibility, page speed ones, and everything. And also, what I would like to say that unit tests are great because they are really great when it comes to pinpointing the place when something goes wrong. But on the other hand, when you already have a big application that doesn't have any tests, maybe it's sometimes better to go with another approach. Just have some more end-to-end testing just to make sure that your application, after all the changes, will work or not. It won't help you pinpoint in which place something is broken, but at least you will know, is it good enough to release or not? And having this safety net, you can start creating all the additional unit tests. Because in the end, yeah, they are very useful, and I can't imagine working without them. On the other hand, when we look, for example, at the WordPress case, there is a lot of mocking. There is a lot of mocking, or on the other hand, very often like functional testing is used kind of like unit testing, because so you have always access to the WordPress core. Yeah, it works. I mean, in some way, but. Oh, and one more thing, because you mentioned a bit about coverage. So, what is
Mhm.
your take about this having 100% of coverage? Do you think it's worth it or not? Or
Um, it's yeah, is it worth it? I mean, it's always a trade-off between how much budget you have and how much security you want to have in the end. But just speaking of the number, when I mentioned that 100% coverage doesn't mean that it's all completely tested. It is worth it because it means that you at least have every single line of code, and most important things are the conditional statements, obviously, that you have them in a test. But I wouldn't be standing and just telling people I have 100% code coverage, because it doesn't mean anything about the quality that or that things can break still while having 100% coverage. But you need a goal, and yeah, 100 is good. Why not? But realistic, especially when you add it to add test to an existing project, because if you just saw the refactoring we did in here, I mean, in the end, we had a single class. Now we have all these classes that interconnect with each other and communicate just to have tests. So 100% coverage on existing projects is probably not really reachable without a tremendous amount
yeah,
of
it's
time.
better to start with those critical places and start covering
Yeah.
this from this place. Make sure what is. Yeah, I mean,
Probably
it's always.
go with a Cypress test instead, because that really tends the end-to-end behavior. And if you have some edgy cases deep down in the technical area, that might not make a difference in that case if Cypress is green.
Yeah, and on the other hand, it's also worth to look at the project from the business side. What is more important? What is less? I mean, let's be honest. For example, if we have some very important API communication like payments, because payments, especially when you have an e-commerce, are like the most crucial thing there is. So this thing is always much more important than, I don't know, for example, we have a wish list or something like this.
Yeah.
Okay, so the wish list won't work. It happens. We did not lost as much money as we would have by not having a payment gate. So yeah, it's
Exactly.
always worth to look at it from the business perspective.
Yeah,
Okay,
and
so
always test manually. Still, always testing manually
that's
is
true.
just mandatory.
Yeah,
Still.
because it's always very important that automated testing is kind of dumb, because you provide it with some instruction and it follows it, and it's great when it comes to it. It doesn't get bored. It will repeat all the tests over and over, and this is terrific. But it won't spot any other bugs,
Yeah.
any other things that you can just see by clicking through it. So this is also a very interesting approach that is always worth considering. I remember that I had a webinar, I forget the name of the company, about crowd testing. So you hire people that test for you. You just provide it with the instruction, with the instruction, and apart from going step by step with the instruction, they also sometimes find additional bugs, and yeah, and that's good for us, because
Yeah.
sometimes we can miss it, especially when we are developing something. We are so focused on it, we
Yeah.
sometimes don't see something that is illogical, because we think, yeah, it's kind of usual that I have to double click on something, and the person from the outside will say, no, it's not. Never. It wasn't ever.
Something that
Logical.
I always recommend when it comes to testing. So one thing, I think there's a name for the, at least it could be in English, pesticide paradoxon, the automation. It always finds the same, but no new bugs. I do have a recommendation as a person, as a developer, when it comes to testing. So not so much technically, but I always try to switch to a completely different role in different aspects of where I'm at, the stage at where I am with the particular project. So that means if I create something as a developer, I usually go the unit testing way. But as soon as I unit test, I think about, okay, how could I break the class? What does it really make sense? And suddenly things pop up. Why is that function public? Doesn't really need to be public. Doesn't really make sense. Why I didn't discover it while developing it? And later on, when I'm testing in the front end, the end-to-end part, I'm completely trying to decouple myself from being a developer. Still being smart enough to know how it's connected to each other, but trying to really be a different person and not only verify, but also validate. Does it really make sense what I try to develop? Does that text field even make sense? So in every single stage of the development process, when it comes to development and testing, unit and end-to-end testing, you can always try to be a different type of person, a different role, and that helps you to figure out that it's better to not release it today with that kind of source code.
Yes, that is true. And yeah, but let's be honest. Sometimes after a long night, it's kind of difficult to like decouple yourself from, because you are like inside of it and you are thinking only about. And in such cases, it's quite a common mistake that you start following the happy patterns because you just want to release something and have it out of your way. And and so that's why really having a separate QA person that just isn't yourself, it's a very important thing that can help you a lot. So Christian, thank you so much for this. I really hope that everyone learned a lot. I did. I also must say that I really love this one comment we got, that coffee to code converter interface.
I just saw it.
Yes, this is really something beautiful. So yeah, and I think that this will be one of our mottos for future episodes. So Christian, thank you again, and I hope that in some time we will think about something else, right? Because it's always a great way to spend the day talking about code and coffee, right?
Yeah. Excited for the
Okay.
second show.
Okay, so thank you everyone. Thank you for being with us. And if you like this show, don't forget to press the subscribe button under the YouTube video. And have a great day or night or whatever. Bye everyone.
Thanks for having me. Bye bye.